Greetings, everybody. I will give, it looks like there's still a few people coming in, so I'm going to have us wait just one more minute so that everyone who is coming can hear everything that there is to be shared. Okay, so I am going to record today's session for anyone who is unable to join. And so I'm going to start that recording now. Great. So we are now recording for today's talk about my image and video computing group. So diving in, what do we research in the IVC group? What are the research opportunities and what are some tips for fulfilling a research journey? So that's going to be what I'm going to cover. And at the end, I'll leave plenty of time for questions. With that said, if you do have any questions during this talk, do please interrupt. You can either unmute yourself and ask the question, put it in the chat. Either is totally fine. You can also raise your hand and I'll call on you. Okay, so diving into what we do in the IVC group. It's important to recognize that all the work is done by the students. And so this is pictures of my team, both from former and current PhD students. And so the two on the top have both graduated. One is currently the responsible AI tools area lead at Microsoft, and another is a research scientist at Facebook Research. And there will be more in the pipeline moving on to perhaps industry in the next year or two. And so the focus for my team is analyzing and synthesizing visual information. To make that concrete, I would like to go through the specific projects of the members of my team, from those who have graduated to present. So starting with Dr. Marnoush Sameki. Her particular project was really addressing the issue of needing high quality annotations. That can be either for a downstream application or for training data for machine learning algorithms. And her goal was to more efficiently collect these high quality annotations, noting that when you go to online crowds where you pay people who you don't know money to come and do your work for you, the traditional way that you do this is you will take annotations from different people and you will fuse those in order to come up with your final result. So let's make that concrete. You might have an image like that shown on the left, and you might go to the crowd and ask 3 different people to demarcate the boundary of the plane in the image. And what you can see is that different people will come up with different quality results. And again, historically and even presently, lots of people will just collect many annotations and then average those. And so when I say average them, the hope is that you are going to get something that's not so like the first one, really good like the second one, and not really poor like the third one. And so the idea from the student who has since graduated was to, given an annotation created for an image, predict whether the quality is good or poor. So rather than needing to collect multiple, perhaps only collecting one annotation. And so the solution that she developed was a regression system that can predict the quality, where the quality can range anywhere from bad, being a score of 0, to 1, being a perfect score. And so in this regression system, she went ahead and figured out what are some features that might be predictive of the quality of an annotation. And then she trained a model, which we'll see here is our beta, such that when given a future annotation of an image, it just pulls out these features and it multiplies that against the pre-trained model's values to come up with a prediction of the quality. And so ultimately, with this prediction tool in hand, she was able to come up with a more efficient way to collect annotations, such that she would say, okay, well, we chose a threshold for what is going to be high quality and what's low quality, collecting annotation from the crowd. We see that the predicted score is low quality. So we say, we're going to throw that away. Let's go grab another one. And now we see that that quality is predicted to be much higher than what is the threshold. So we say we can keep it and move on to the next image. And ultimately, with this approach, what was found is that she could achieve the same accuracy as the status quo of using 5 annotations, which is the status quo, while eliminating 50 to 73% of time and cost. And so that was the culmination of her particular PhD. My second PhD student, Dr. Yinan Zhao, worked on a lot of different tasks related to how do we take images where we don't like something about them, such as this image in the top, where maybe we don't like that red region. And we want to come up with new alternatives that might look better. And there are many possible applications for this. This includes for personal photo editing, for advertising, landscape architecture, augmented reality, interior design, privacy obfuscation. There are many applications where you'd want to do this kind of hole filling or image painting. And so the status quo prior to his work was you would have some sort of image and you would go search a massive data set where you have different kinds of objects. You find the object you like, put it in that hole, and then you would synthesize the content of the background so that you have a realistic looking image. So my student's idea was, well, that's really time consuming to have to go and browse through these libraries of different images to find some content that might really look good in this hole. Why not instead have an algorithm be able to automatically identify from a database of images what are the compatible objects in that database? And so that's what he did. In summary, he basically came up with a way to learn how to encode an image and each one of these candidate objects into a latent space where there's a common distance between the image and each of these objects, such that objects that are really similar will show up very similar in location to where the image is located, whereas objects that are not compatible will end up being pushed really far away. And so that is the intuition of what he did. And ultimately, then it would tell you, okay, here's the objects that are most compatible with the image. And so the really cool thing about what he developed is that it could both recognize when in an image, there should just be one kind of a thing, such as catchers, or when there should be a diversity of content, such as, banana, cake, hot dog, and so on, that might sit on a table. All right, so Samri Nanjum is a senior PhD student in my group, and she's been looking a lot at object tracking. And her work has looked at both developing data set challenges, where the goal is to track individual cells predominantly to help biologists understand basically what's the behavior of cells and how do things like cancer spread, how do we create blood vessels and understand how biomaterials can be made. So she's developed data set challenges as well as benchmarked state-of-art algorithms for seeing how well they can follow objects over time. And she's also currently developing some hybrid human-machine partnerships to come up with high-quality results with limited human involvement. Taiyin Chu, who will probably graduate in this next year, has been working a lot on style transfer. So given some sort of image, let's say you want to change its appearance, you can actually do that by saying, here's the content that I want to have, and I want to have it in the style of this other image, and you could get a result like this. This is available on many, many mobile phone applications. Some of you have maybe used this to, for example, show your face to appear like, like a Picasso painting. And the challenge with a lot of these is not only how can you get high quality results when you render the content in the style of another image, but also how do you do it with as few parameters as possible? Because often we're running these applications on mobile devices for fun. And so what the student has developed is a system that, compared to existing models, requires fewer parameters, only about 70% of the parameters, while supporting higher resolution images and achieving state-of-art stylization speed. So basically, this is going to be the state-of-art algorithm out there that enables for the fastest stylization and the support of the highest resolution images. Okay, got 2 more projects to go. Another student of mine is Changin Chen, and her interest is trying to locate the evidence that is needed to answer questions about images. So let's say you have a task such as shown here, where you have a person who takes a picture. In this case, it's going to be often people who are blind is who my group works with. So they don't know what's in the image, but they say, you know, what is this? The goal is not only just to return the answer, but also return the location where that visual evidence is, where the answer can be found. This is useful for many reasons. One important reason is that often, if it's a person who is blind who's taking the picture, but you could also imagine this for people who are sighted, inadvertently, people can get private information that shows up in the background that they would not want shared with the public. And so if you can locate just the region that is relevant for providing an answer, then you can say, let's get rid of all the context and only rely on that region we need. And we can, for example, share it with a human to help us confirm if an answer is valid. So it can be used for privacy preservation. Also, there are many people around who have some sight, but it's not great sight. They can't drive, for example. They don't have 20/20 vision, and they can't correct the vision such that they could. And so for those people, they use what are called magnification tools. So basically they go around either with a magnifier or on their mobile phones, they'll zoom in all the time. And so the idea is that someone can ask a question, and then we can use that grounding to automatically magnify just the content that matters. And so my student has actually not only developed a data set challenge to support grounding the answers, but also has developed some algorithms that can automatically locate where the evidence to the answer is located. Josh Myers-Dean is a new student, and he has recently published or submitted for publication a paper on a task called few-shot semantic segmentation. So the idea is that given an image, you want to locate predefined categories, such as a sheep, bus, monitor, cow, or car. So you can see, for example, in this 4th row, you can see that there's some cows. And so what we see here is, this is the ground truth annotation. This is what we're looking for an algorithm to create. And the observation for this work is that often we don't have large amounts of data available to help us train models to do a good job at our task. So what he did was he came up with a way to be able to train models such that you only need to see one example of the thing you're trying to locate. So let's say I'm trying to locate a Frisbee that I have, and it's a Frisbee that was specially created for me. I could take one picture and train my machine to recognize that one, that type of Frisbee going forward from just one picture of it with the annotations of it. Or let's say you are going to do it in the case where you have 5 examples or 10 examples, or we're getting to the more traditional case where you can actually have many examples, which is 100-shot. So this is a space called few-shot learning. And my team, and in particular, Josh, has been working quite a bit on doing this for the semantic segmentation problem. And the final two students are still first year students, so I will be talking next year about the work that they produce. What you have seen has come from a variety of sponsors. Our primary funding sponsors are the National Science Foundation, Microsoft, Adobe, and Amazon Mechanical Turk. Okay, so I want to take a pause at this point to see if anyone has any questions. Okay, so now I'm going to share a little bit about what are the research opportunities for specific projects we have in our group. One is for a task called foreground object segmentation. So the idea is, given some sort of image, detect that most prominent object in the image. This has been done before, but what we are doing this for is for a new set of images that come from people who are blind, who in their daily lives were trying to learn about their visual surroundings. And as a result of them being blind, there's a risk that there's private content showing up in the background. So that's the application that motivates this project. But what's also really important about this project technically is that these kinds of images are really different than what people have looked at for the foreground object segmentation problem in the past. So as shown in this image, text is often present. That's not the case for most of the other data sets that exist. And often you have varying image quality. You can have things that are fairly zoomed in, which is actually quite common if people are trying to learn about content they take pictures of. And so in this project, the task will be creating a large scale data set. We already have the images, so it'll entail doing some crowdsourcing. You'll get to spend a lot of money to ask people on the web to come and help us locate the most prominent object. Then evaluating the state of art algorithms that exist and seeing how do they perform on this new data set. Likely they'll fail miserably, and so helping us understand what makes them fail, so we can then turn around and think about, well, how do we design improved computer vision models? So that's one project. And then the other project is for object tracking. And so here I'm just showing some scenes. This is, again, people who are blind who have captured footage of things that they have. And so you can see, they can't necessarily perfectly center the content of interest. Sometimes it's a beautiful space where you have one clear object of interest. But other times you can see that there's clutter, and in that clutter might be some private information that we don't want publicly shared. And so the challenge here is trying to track objects of interest. So this is going to sit within the semantic segmentation space, but it's through tracking as well, because we have the element of video and time. And so this task will also involve data set creation. We have the videos, and so it'll involve leveraging some tools we have in-house to, again, do some crowdsourcing, spend lots of money, then evaluate state-of-art algorithms for object tracking. And of course, I expect for those to fail miserably, because often they do for real world use cases. And so helping us understand why are those failing so that we can turn around and design a new computer vision model that does a much better job. And again, this is going to be pertinent to a real world application of helping people who are blind. In this case, we're going to be focusing on tracking private content in images, such as a wallet. Okay, so if you are interested in the projects available to me, you can email me at my email address. I'm putting it here. Feel free to take a screenshot. I know there's going to be a recording of this talk, so you can grab this afterwards, or you can go to my website. But to apply to conduct research on either of these projects, go ahead and email me at my email address and include the following: either your resume or your curriculum vitae, names and contact information for 2 references, your transcripts, as well as a 2-page essay explaining why you want to conduct research, which projects you're interested in and why, and any personal development goals that you have for this role. And any applications that are received before 5 p.m. on Monday, January 3rd, 2022 will receive highest priority. So any questions about that before we move on to the final portion of my presentation?
I have very small question about project one.
Yes.
Yeah, so how similar or different is it with salient object detection task?
So this is going to be salient object detection. There's not a full convergence in the community about what all this means. So sometimes when people are talking about salient object detection, they're going to talk about everything that looks like it's prominent. So in this case, you only have one thing that looks like it's really prominent, but sometimes you can have more than one object that looks prominent. And so that's just, different. Some people, traditionally we see foreground object segmentation, you're talking about locate just one object. Salient object detection can be more general, where it says find multiple things if needed that are all going to be really prominent. Does that answer your question?
Yeah, got it. Yeah.
Okay, thank you. Any other questions?
Hello.
Yeah, please.
Oh, hi. Thank you so much for this. Okay, so my question is this. The two projects are actually really amazing, but is there still possibility to also bring your project of interest perhaps? If you have a project of interest aside this, or do these two receive the most priority for now?
Yeah, so you're certainly welcome to bring another project to my attention, just because I have a broader notion of if it's not clear, I have many projects going on. And so it might be that one of your interests actually fit really nicely with another project we have in-house. So you are definitely welcome to send me about another project you have, an interest you have, and I will review that to see if that might be a good fit with the momentum of our group at this point. Likely for another project, you would, in the case of these two projects I described, I would be more the senior person leading the projects, but you would, while having access to me, likely be paired up with a graduate student that I have to kind of contribute to the momentum of that student's project, assuming that you have an interest that falls in line with one of my students.
Okay, thank you so much.
Sure, thank you for the question. Any other questions? Okay, so last, whether you join my team or another team, at Boulder or elsewhere, I think a question is what makes someone successful in research? And over the years of working with students, I just wanted to share a little bit of what I've witnessed. It's going to vary a little bit from group to group, but generally what I found are that the following qualities matter the most. So first, make sure you're a self-starter. Generally, you can procrastinate, but I found that it's much harder for people who tend to procrastinate. Really being a self-starter and constantly having the initiative to go beyond the scope of the project and teach yourself where you feel like you have gaps is going to be a real sign of success in a research environment, because there's not a lot of hand-holding. And that's just, if you learn that you're not big into being a self-starter, that's totally fine. There are many jobs where that's not an important skill, but in the space of research, that's a really important skill to have. Another thing that really matters is because we often just don't know how things are going to work out. It's research, right? We don't have the answers. We're figuring out as we go. And while that's really exciting, that also means that often things don't work out the way we expect to. Things can take longer, or they may not even work because they never should have worked and we hadn't thought about why. And so it's really important to have strong communication skills in research so that we can constantly redefine success. I find people are much happier and succeed much more if they feel really comfortable and confident in communicating about, here's my expectations of what I should have done. here's the status of the progress, and either it worked or it didn't. And let me tell you about why it didn't if it didn't. Okay. Another trait that matters, which I think is going to matter for almost every profession, is just being reliable. So that doesn't mean succeeding at completing the work we agree on, but it means either completing the work on time or proactively communicating if you can't complete that work, right? And often, again, in research, you can't complete what we have talked about. And so we have to redefine success, but being reliable means taking the time to communicate when that is the case. Another quality is persistence, because in research, often things fail. And so you have to really have the stamina to keep trying over and over and over. And lastly is attitude. I generally find that those who succeed in research are going to be people who really just love learning and growing themselves. For some people, that's just more comfortable than others. Having that attitude of seeking to constantly learn and grow is not for everyone. And there are many jobs where that is not expected of you. But in a research space, it's really important because the community is constantly moving and you need to move with them. And it's a very humbling experience. And it's really important to be comfortable with that humbling experience so that you can constantly allow for your growth. And I, as a researcher today, am still going through that. And I've been doing this for a long time. I don't think that ever changes for people who are in research, that it's important to constantly want to learn and grow. And so with that, that is all I have for today's talk. And so at this point, I'm going to stop sharing my screen and we can do an open Q&A session. You can ask me any question. It can be about my research group. It can be about research in general, advice about whether to do a PhD or not. Just for context, I know this is master's students. I actually did my master's degree and I went and worked in industry for 5 years before coming back and doing a PhD. And so, I've done that route. I did research when I was a master's student. And so I'm also happy to share about any of those experiences. And so with that, if you have any questions, feel free to unmute yourself or raise your hand or put a question in the chat. And I'm sorry ahead of time if I mispronounce names, but I'm going to give it a shot. Kunal?
Yeah, so hi, Professor. Regarding the project of exploring the use of deep learning with crowdsourcing to annotate images, so where you have given the future scale that active learning could have a significant impact. So I was wondering that, is that project still in your priority?
Great question. It's definitely a priority. I think that data annotation is, it's definitely one of the problems that matters most, because you can't always look, if you're a big company like Microsoft or like Google, it's a lot easier to get big data, but many people aren't Microsoft and Google. Many innovations aren't those. And so being able to figure out how do we collect annotations that are going to be most fitting to train our models is important. So yes, I think that is important. It's not our current direction because I actually think there's more hope in other directions. And the reason I say that is because active learning has been around for a long time and I've explored it some, but I think right now there's spaces that we don't know as well, like self-supervised learning. And so that's kind of the direction I'm going, but I'm certainly open, if students have ideas, like just because something's old, it doesn't mean it's not great. Often old ideas get reinvented and yeah.
Got it. Thank you so much.
Sure. Okay. Abdul?
Hello. Hi, Professor.
Hi.
So one area that is mentioned in the lab's website is biomedical image analysis. So is your group planning to work in this area? And
yes. Yeah. So my group actually currently does. So I mentioned the work of my student, Samreen Anjum, who is working on tracking objects. And a lot of what she's looking at is tracking individual cells. But that's not, I guess the answer to your question is yes, because biomedical applications are just applications. And generally in the spaces I live in, you're not publishing for an application, you're publishing for an innovative algorithm or data set or idea. And in order to show that that innovative algorithm or idea generalizes, you need to show it across different application domains. And so showing it in the biomedical domain is one way to show that an idea generalizes. And so the answer is yes. And it's just important to understand that the application space is a means to an end rather than the end for the communities we live in, because we're really considering coming up with ideas that can generalize to any application, and we just need to prove it on some handful of applications.
Got it. Right. Thank you.
Sure. Okay, let's see what's in the chat. So I see a question. Are the applications for research opportunities only for students at CU? Yes, that is correct. The opportunities are going to be only for students at CU. And another question is, would you be integrating computer vision projects similar to those mentioned today in your deep learning course in the spring 2022, such that we get a taste of computer vision? Yes, I will. I'll caveat that with the class that I'm teaching this spring, which is called Neural Networks and Deep Learning, is a much broader, it covers a much broader range of topics. So it will cover the techniques that are used in computer vision for a few weeks, but it will also cover on ideas that come from natural language processing. And we'll also touch a little bit on reinforcement learning and speech. And so this comes back to my response to Abdul earlier. Often when we think about neural networks and deep learning, and this is true also in the computer vision community, we're looking for general ideas, which means that those ideas aren't specific just to even computer vision. You know, those ideas could generalize to analyzing audio signals or language signals. And so the class that I'm going to teach this spring is really going to talk about those general ideas and show how ideas that were born, for example, in computer vision, have influenced other domains such as natural language processing, and how ideas from other domains such as natural language processing, and for those who are familiar with buzzwords like transformers, how those are coming and influencing other fields like speech processing and computer vision. So my course in the spring is going to be a much broader reach than what I would teach in a computer vision course. Okay, so I have another question in the chat. What motivated you to come to research, quitting the industry job, which I guess would have been much lucrative? Great question. Why did I decide to leave industry after 5 years when I already had a master's degree in computer science? So at that time, I went through a major life event, and it was a loss in my family. And that made me kind of look inside and say, what's really important to me? Like when you can just lose someone with no notice, what really matters at the end of the day? And I spent a lot of time reflecting. I often find moments of growth come from loss, and that was true for me. And so I spent a lot of time, thinking about what really matters to me in life, given that life is so fragile and short. And it occurred to me that my passion sits in mentoring people. Unquestionably, the thing that makes me light up the most is watching when people I'm talking to, whether younger or older, or my peers, discover something new about themselves and being a part of that process. And so that was a big part of why I decided to go back to school. I didn't know that I was going to become a professor. I didn't have that agenda, but I did know that I loved the educational space. I really, really loved being a part of helping people grow and learn. And so that was, I guess, that was the reason I stopped being in industry where the currency is about making money. And I moved to academia where the currency is about learning. Okay, any other questions? Okay, so I see Isaiah.
Yeah. I was wondering, in terms of skill sets, what skill sets do you look for among the students that you're like candidates to do research with you? And what skill sets would you say that people develop above all else while doing research with you?
Yeah, the skill sets I think that matter the most are the soft skills. And so I guess it's back to, I'm just going to show a slide just one more time that I had shared earlier. I'm not sure,
Sure.
Just to emphasize this, because I think this really, I've spent a lot of time thinking about this because I've worked with a lot of students and I see those who thrive in research and those who don't. And I want to say that if someone doesn't thrive in research, that's totally okay, because not everyone is designed, everyone in the world can't be researchers. But when I've thought about what are the skills from people who thrive in research, it's going to be those on this slide. And so these are really soft skills. It's really about feeling like you're a part of a team. So constantly communicating and trying to help the team move forward by like looking for answers and being reliable and having an attitude where it's just, you want that, you know, like you wake up every day and you just say, this is incredible. I can't believe someone is supporting me to do this. I can't believe someone's mentoring me. Or if you're so fortunate, which I was in my PhD, not my master's degree, but if you're so fortunate, someone's paying you to do this. And so that's really what I think is going to matter the most, are these kinds of soft skills. And it's not just about developing the skills. I think it's really about looking inside your heart and saying, does this really make me tick? Because research isn't, you can get a much higher paying job. You can get much more prestige going outside of research. I really think that research is about having this deep burning desire to answer questions. And beyond that, everything else can be learned. You know, if anyone's in a computer science department, you know how to program. You're learning, you know, you're going to take courses that fill your other gaps, and you're going to work with your peers. And ostensibly, as long as you're a self-starter, you're going to go and find online courses or books to fill the gaps that you have technically. So for me, it's the soft skills that matter the most. The hard skills can be learned.
Great, thanks. If I can ask one more, a little more personal question, I'm very interested in geospatial data sets, in particular in satellite imagery. Would you consider that an application of your work? Is that something you've worked with directly before? Yeah.
Great question. Yeah, so geospatial is going to be an application. So let me kind of, for everyone's sake, let me talk about what makes something an application versus an idea. So an application is, I have data and it's in the format of a grid, which is a grid of pixels, or over time, it's going to be a series of images for video. Okay, so plop in anything into that equation and that's an application. So geospatial images can plop into that. That's an application. Images for people who are blind can plop into that. That's an application. Biomedical stuff can plop into that. That's an application. So that is totally fine for my group. Again, the idea will be though that you would need to show generalization for your findings. So just showing it works, you know, something works for just one application often isn't enough. You have to show across different applications, and that can be done. Has my group looked at it? Not my immediate research group. I have had numerous students do final projects in my courses on this topic. And my husband is actually in this space. And so I spend a lot of time talking with him about this. So I definitely know something about it, but it's, you know, my application expertise is not on geospatial data, like that niche of it. It's just on, hey, if it looks like it can be put in an image or in a video, I got it. Does that answer your question?
Yeah, it does. Thanks.
Sure. Okay, so I have some more questions in the chat. One is, I'm an undergraduate student. I've applied to attend to graduate school at CU Boulder next fall. Can I still submit an application to join your research projects, or should I wait until I enroll at the university? I would say wait until you enroll at the university. Yeah, just, you know, make sure that you're committing to coming to Boulder is going to be important. Okay, another question from Nishant.
Hello, hi. So I was wondering if you would be open to taking up other ideas that we might have thought of. So I saw the 2 projects, and I think I have another idea. So would you be open to taking that up? I mean, it's obviously related to computer vision. So
Yeah, so this is going to align with a response I had earlier. So you are welcome to send me the ideas you have. And as long as I can see how it fits into the broader momentum of my group, then that could work out. Let me explain kind of the motivation of why I say that.
okay.
Like, why am I selective about which projects I take? So I am a professor who, let's say in theory, I work 40 hours a week. Okay, let's just say that in theory. If we do the math, well, every week I'm teaching some number of hours, and I have to mentor each of my students. And I also have to do my service load, which means that my ability to meet with a master's student and think about that project is probably going to be somewhere between 30 minutes and 2 hours a week. And so my ability to really support a student in success is going to be limited if I'm not immediately close to the project, or if I don't have a student already that is immediately close to the project. And when I take on a student, I don't just take on a student for the sake of growing. I love my job. I love working with students, as I've said. And so it's really about my passion and wanting to make sure that we're all winning. We all feel good about it. And winning doesn't mean that we have publications and we're successful in the research, because we fail in research, but it means we're all really enjoying it. And so I don't take on students that are too far from my space, because I can't ensure that the students are going to be supported and we feel like we're winning together. And so I feel like I'd be letting a student down. And similarly, I think a student might feel let down if I can't allocate more time to make sure that the student's really on top of the curve in a space.
So would you say that self-driving is fairly in your domain, self-driving autonomous vehicles and stuff like that?
Yes. Now, let me speak a little bit to that, just for those who are choosing research projects. I will not go onto self-driving vehicles. Why? Because then I'm competing against all the major companies who have pumped billions of dollars. And I assure you that we are going to fail in my group. But what I can tell you is that the students who are graduating from my group and my peers are working at those companies and are getting job offers from those companies, because we all have the skills to be able to go into that space. And so when I choose a project, I also want to make sure that the project has the greatest chance of success. And part of that means not competing against the major players, because you can't win when you don't have thousands of GPUs and tens or hundreds of researchers at your whim to help you get to success. And that's going to be the situation with self-driving vehicles. Now, yeah. And just, to be clear, like if you're just thinking about self-driving vehicles, you're just thinking of an application. Hopefully there's an idea you have, and that idea we can say, well, let's pull that out and apply it to another domain, because we know it applies to self-driving vehicles, but let's make sure that we make this so that it could be publishable or successful in the world of the research community.
Okay, thank you. Thank you so much.
Sure. Okay, let's see in the chat. I do not see any additional questions in the chat. And I do not hear any additional questions from people in the audience. And so I guess at this time we can end, but I will stay on after I stop recording for a little longer. So if someone wants to ask a question outside of a recording, you're welcome to. So I'm going to go ahead and stop recording now.